Hello everyone, I hope that you are well. Let's get straight onto the extensive exercises for our distance lesson that we did. So we've been told over here that a car drives from city A to city B. If the car increases its speed by 25%, it will finish its journey 30 minutes early. Find how long it will take to drive from city A to city B if it increases its speed. So the first thing we need to do, everyone, is actually just write down the increased speed, and we're going to write that in the ratio of 1 to 1.25 because there's been an increase of 25%. So we're just going to be adding that onto the whole. Then we don't really want this decimal, everyone. So let's just multiply the ratio by 4, and that would give us the ratio of 4 to 5. So the ratio of the speed is going to be 4 to 5. Now remember, speed and time taken are in inverse proportion. Okay, they're not in direct proportion, they're in indirect proportion. So if we know that this is the ratio for speed, we know that the ratio for time taken is just very simply going to be 5 to 4. Okay, so that's going to be the ratio for time taken. And finally, we know that the difference in the time is 30 minutes. So we know that each part is equal or equivalent to 30 minutes. And we want to work out how long it takes to drive from city A to city B if it increases the speed. And so that is just going to be our parts multiplied by 4, because it's the part over here that we're trying to figure out, and that's going to be 120 minutes. Okay, so that is how you would do I. Now let's have a look at II. They've said if the car decreases its speed by 15 kilometers per hour, it will then take 1/6 more time than before to finish the journey. What is the usual speed of the car? So let me just clear everything so that I can write II. Okay, so now we've got a decrease of speed by 15 kilometers, and over here we know that it will take 1/6 more time than to finish the journey before. So we know the ratio of time taken is very simply 6 to 7. Okay, so we've got that ratio of time. Now remember that speed and time are in indirect proportion. So we know that the ratio for speed is just very simply going to be 7 to 6. Okay, now they've told us in the question that the car has decreased its speed by 15 kilometers per hour. So we know that the difference in the ratio, which is 1 part, is equal to 15 kilometers per hour. So we know that 1 part is equal to 15 kilometers per hour. So we know that the usual speed, remember this part represents the usual speed, this one represents the decreased speed, is just going to be equal to 15 multiplied by 7, which is equal to 105. So the usual speed of the car is just 105 kilometers per hour. Okay, let's have a look at question number 2 now. So without further ado, let's go on to that. Oh, let's clear the drawings as well. Great. Okay, let's have a look at number 2. Mike travels from his home to office at 4 kilometers per hour. He reaches his office 20 minutes late. If his speed was 6 kilometers per hour, he could have reached 10 minutes early. Find the distance from his home to his office. So we know that as the speed increases, the time taken decreases. Okay, that's that's what we learned in the lesson, and therefore it implies that there's indirect proportion, and it's pretty much the same with this problem as well. So we know the ratio of real speed to usual speed is going to be 4 to 6, and that can simplify down to 2 to 3. So that's the ratio of the real speed to the usual speed. And because, you know, I did earlier say that speed and time taken are in indirect proportion, we know that time taken ratio, so the ratio of time taken is just going to be 3 to 2. Okay, and now because we know that the time difference is indeed 30 minutes, so the time taken would just be 3 multiplied by 30. Remember, this is the part that we're trying to work out because that's the ratio of the real speed, and that's going to be equal to 90 minutes, which is equivalent to 1.5 hours. Okay, and so remember, distance is just, we want to work out this total distance from his home to his office, and that's just going to be equal to the speed multiplied by the time. So it was just going to be 4. Remember, the 4 is the speed, and then if we multiply that by the time, that's just going to give us 6 kilometers. Okay, so that would be our answer for this second question. Let's get straight on to number 3 now. Okay, so number 3 states that Edward goes to school on time every day. If he increases speed by 20%, he can reach the school 8 minutes earlier. How long does it take for him to get to school after the speed increases? Now remember, again, we've got the usual speed, and then we've got the speed after the increase, and then we can just convert that into the whole numbers, which would give us 5 to 6. Okay. So once we've got that, we know that's the ratio of the speeds. The ratio of the speeds is equal to 5 to 6. But remember that, you know, the ratio of the speeds and time taken are in indirect proportion. So we can say that the ratio of time taken is very simply just going to be 6 to 5. Okay. We know the time difference is 8 minutes, so we know that one part is equal to 8 minutes, and the part that we're trying to work out is after, is after the speed increase. So this is the part that we're going to work out. So because we know that one part is equal to 8 minutes, we can just do 5 multiplied by 8, which is equal to 40 minutes. Okay, so your answer for this one, it should have indeed been 40 minutes. And without further ado, let's get straight on to the extensive challenges. Now, question number 1 should have been pretty straightforward. This one, just remember that you've got a 40 minutes increase from the school journey, so your answer should have indeed just been 9 AM. And let's have a look at number 2 now. So Jack and Jill went up a hill. They started at the same time, but Jack arrived, let's move that. But Jack arrived at the top 1.5 hours before Jill. On the way down, Jill calculated that if she had walked 50% faster and Jack had walked 50% slower, then they would have arrived at the top of the hill at the same time. So those two actually, you know, we can kind of say are equivalent in a way. Okay. So those two would basically just be equivalent in a way. All right, then how long did Jill actually take to walk up the hill? So we know that when they walk up to the top of the hill, they will basically be reaching the hill at the same time. And we know that that happens when Jill, of course, walks 50% faster and Jack has walked 50% slower. So we are going to be having the usual speed of Jack multiplied by 1 minus 50%. And we know that that has to be equal to usual speed of Jill multiplied by 1 plus 50%, because remember they arrived at the top of the hill at the same time, so those two would have to be equivalent for that to actually occur. So we've got usual speed of Jack multiplied by 0.5 is equal to usual speed of Jill multiplied by 1.5. Okay, now if we are just going to be, making the ratios and simplifying them, because right now we have them in terms of decimals, we would get the ratio of usual speed. So ratio of speeds as 3 to 1. Okay, and remember that speed and time taken are in indirect proportion. So time taken by Jack to Jill would just be 1 to 3. Okay, and now we just have to work out how long did Jill actually take to walk up the top of the hill. Okay, and that would very simply time taken by Jill, it would just be 1.5, because remember Jack arrived top 1.5 hours before Jill, but then we have to divide that by 2. Okay, and then we've got 3 parts over here, so we're going to be multiplying that by 3 to get 2.25 hours. So guys, hopefully that helped you all, and I hope that you've enjoyed the lesson this week as well.